Okay, so let's get back and let's do another example. So here's one that we're going to use this strategy for. So I'm going to tell you a particle moves with velocity v of t equals t minus 1 cubed, and I'm going to tell you to find the total distance traveled from t equals 0 to t equals 2. And just right away, when you're reading a problem like this and you read this phrase, total distance traveled, that should immediately think, oh, that's a key phrase, TDT, that's integral absolute value velocity. So I got to use this special case. Okay, so this is equal to the integral absolute value of t minus 1 cubed. Okay, so what are we going to do with this? Well, it's a t minus 1 cubed, so we're going to split this up when that inside equals 0. So we set the inside equal to 0. So I'll cube root both sides, t minus 1 is 0, t is 1. Great. Okay. So let's split this up into integral 0 to 1 of t minus 1 cubed plus integral 0 to 2 of t minus 1 cubed. Okay. Now for both, I should have split that 1 to 2, not 0 to 2, my bad. Now for each of these, we're going to need to do just a mini u sub, right? Because I have not just t to the third, but t minus 1 to the third. So my u is t minus 1, my du then is just a dt. Okay, so this just becomes, we got to change the bounds too. So t was 0 to 1. 0 minus 1 is negative 1, 1 minus 1, 0. So that becomes integral negative 1 to 0 of u cubed. Okay. And that's not bad, right? That's u to the 4 over 4 going negative 1 to 0. So that 0 minus negative 1 to the fourth is positive, so 1/4. Okay. The one on the right uses the exact same u, right? I just need to change the bounds here. So t goes 1 to 2. 1 minus 1 is 0. 2 minus 1 is 1. So that's integral 0 to 1 of u cubed. So that's u to the 4 divided by 4, going 0 to 1. So again, that's 1/4. So now, when I take the absolute value, those are my two parts. So my answer for that total distance is absolute value negative 1/4 plus 1/4. I take the absolute value of each part, just like we did in the last video. Absolute value of each part. So 4th plus 4th gives me 1/2 for my total distance traveled. Okay, so that's how I do a problem like this. Now let's look at one where we have a graph. So let me say I tell you, here is a velocity graph. So not an equation, but a velocity graph. So I'm going to give you my velocity and some time. And let's say we split it up at 5 and we split it up at 8. So your velocity starts off like this, and then it goes down, it looks like that. All right. So I'm going to tell you right away in the problem, I'm going to tell you this area up here is equal to 3, and I'll tell you this area here is equal to 1. So now, if I just asked you to find, say part A of this problem, I will ask you to find the net distance traveled, or the net change in position. Which, by the way, another word for net change in position, you might see the word displacement. That's all displacement means. Like, what was your displacement, your change in position from one time to another time? Okay. And the net change in position, the way you do that is like we did at the start of the day. That's just the integral of velocity. So if we want to find the net change in position from 0 to 8, it's just integral 0 to 8 of velocity. Okay, so we have a positive 3 above, and then we have a minus 1 because we're below the curve. So my net change of velocity is just 2. Now, the other thing I can ask about, is the total distance, go away, okay, is part B of this, is I can ask you to find the total distance traveled. Okay, and the way you're going to find the total distance traveled, okay, there's that phrase, total distance traveled. So right away, you're like, okay, I'm integrating absolute value of velocity. And if you're given a graph, the way you're going to integrate an absolute value is you're going to treat all area as positive. So instead of doing a 3 and a negative 1, you're going to have a 3 above the graph and a 1 below, but you're going to add them. And that's because of the absolute value. That's what the absolute value means. So if you're looking at this graph, you're saying, okay, I walked like 3 miles in the forward direction, and then I walked 1 mile in the backwards direction. So my total change in position was only 2 because I went forward 3, backwards 1. But my total distance traveled was 4 because I walked forward 3 plus I walked backwards 1. So I add those together and get 4. So basically what I'm doing is what I did in the previous problems. I'm splitting it up at 5. I'm taking the absolute value of each part, absolute value 3, absolute value -1, and adding those together to get that number. Okay, that's total distance, absolute value integrals. I'll see you guys in class. Let me know what didn't make sense.